This section is over exponential functions, including compound interest. But before we even get into functions and interest, we are going to go back to college algebra and we are going to review. So we are going to review the exponential rules that you should have learned a long time ago. So we have all of them here. I'm going to talk about the last ones first, 6, 7, and 8. And the reason that I talk about these first is because these are ones that you should automatically know. They're just at the back of your hand because we have used these continuously in this course. So we know anything to a zero exponent simplifies to be 1. We know anything with a negative exponent flips the fraction and moves it to the other side of the fraction. And we know if we have a fraction in the exponent that is redefined as a root, where we have the denominator of our exponent is going to be what is in the crevice of the root. And of course, the numerator of the fraction is going to go inside the root. So I don't feel like I need to address any of those because we've used those multiple times in this course. So let me shift over through 1 through 5. Okay, I'm just going to run through these real quick, and then we're going to utilize them on some basic college algebra examples. So my first one says, if I have similar bases and I am multiplying those bases, then I can add my exponents. If I have the same bases and I'm dividing the bases, then instead of adding, I subtract my exponents. Number 3 says, if I have an exponent to an exponent, then I can multiply them together. Number 4 says, if I have two bases to one exponent, I can distribute that exponent through and take it to each base. And then the same thing for property number 5. If I have division with one exponent, I can distribute that exponent and I have division separately. Okay, so let us utilize these in some actual examples. Now again, these are college algebra examples, so I expect you to be able to do them on your own. So why don't you pause the video at this time and see if you can get the correct answers. Okay, starting with the first one, if I have 2 to the 3rd over 2 to the 5th, that uses my property number 2, if I were to review back, it says I have same bases and I can subtract my exponents. So this gives me 2 to the 3 minus 5, or 2 to the negative 2. Then I have to use my negative exponent property, which says this is 1 over 2 squared, and that's probably where I see most mistakes. This is not equivalent to negative 4. The negative in the exponent means I flip over my fraction, and that gives me 1 over 4, which is, of course, why it is not negative 4. Example number 2, 16 to the 3/4 is basically just rewriting it in root form. So this is the 4th root of 16 to the 3rd power. Well, I'm going to take the 4th root first. The 4th root of 16 is 2, because 2 times itself 4 times gives me 16. And then I have 2 to the 3rd power, and 2 to the 3rd power simplifies to be 8. So the answer to example 2 is 8. Example 3 is a little bit more complicated, but still utilizing rules that we're pretty comfortable with. So I'm going to first take care of my negative exponent by flipping my fraction. This gives me 27 over 8 to the positive 2/3. And then just rewriting the second part of this fraction. Now I might rewrite what each of these fractions means, and that means I'm going to do it in the root form. But also note that I can distribute those to both the numerator and the denominator. That was property number 5, saying I can distribute a power. So I'm going to distribute it and rewrite it all at the same time. Okay, so that gives me the cube root of 27 squared over the cube root of 8 squared times the square root of 25 to the 3rd over the square root of 9 to the 3rd. So if I simplify all of my roots here, That gives me the cube root of 27 gives me 3 squared. Cube root of 8 is 2 squared. Square root of 25 is 5 to the third over, and the square root of 9 is 3 to the third. So notice in that step I took all of the roots, but I did not simplify any of the exponents yet. And that's what I'm going to be doing in this step. So 3 squared is 9 over 2 squared is 4 times 5 to the third is 125 over 3 to the third is 27. Now I know as fractions I can multiply these straight across, but if I can reduce, I should always do so first. 9 and 27 both divide by 9. 9 divided by itself gives me 1, and 27 divided by 9 gives me 3. So now I can multiply these fractions straight across, and that gives me 125 over 12. And so that is my final answer there. Okay, let us move on to number 4 and 5. Maybe a little bit more complicated, but still we should be able to do this. So 27 to the 2/3 is the same thing as cube root of 27 squared. Same thing with 8 to the 4/3 is the same as cube root of 8 to the 4th power. I'm going to leave this negative 3/2 on the outside as is. Let me take care of these cube roots. So the cube root of 27 is 3 squared. Cube root of 8 is 2 to the 4th, all to the negative 3/2. 3 squared is 9 plus 2 to the 4th is 16 to the negative 3/2. 9 plus 16 is 25 to the negative 3/2. Let me take care of my negative. That's 1 over 25 to the positive 3/2. Now I can distribute this root through. It doesn't matter if I distribute it on the top though, because 1 to any power is just 1 itself. And in the bottom, if I rewrite it, that's the square root of 25 to the third. Well, I know the square root of 25 is 5, and then 5 to the third power is 125. So the answer to number 4 is 1 over 125. Okay, the last one might look a little bit more difficult because we don't see actual numbers, we see the variable e. Well, the thing to note about e is it's not actually a variable. It's not like x. E has a very specified value, and we will review that here in this set of videos. But the thing is all the properties still apply. So we just want to follow the properties that we've learned back in college algebra and are reviewing here in this video. Okay, so I can go about this lots of different ways. I can try and simplify the inside first by property number 1, adding my exponents, or I can distribute this property here, or I could just take care of the negative, or. I can do lots of things here. And so whatever is most comfortable for you, please go ahead and do it that way. Nothing says that you have to do it the same way that I do it here on this video. I'm going to follow my PIMDAS rules, and I'm going to simplify the inside of my parentheses first, and I do that by adding my exponents. So I need to add negative 2 and 1/3. To add fractions, I need a common denominator. My common denominator is 3. So this is the same thing as negative 6/3, because that's equivalent to negative 2 plus 1/3. So that gives me e to the negative 5/3. Okay. Now I'm going to multiply my exponents. And so when I multiply these, my 3's cancel and my negatives cancel, so all I have left is e to the 5 over 4. I cannot do anything more with it unless I want an approximated value, and I could type that in the calculator if need be, but I believe this is all the farther that we need to go on this example. I am going to stop this video here. In the next video, we have one more exponent rule that we need to review so we can solve equations that involve exponents in it.